All right, so for today, here's what we're working on. We're working on roots and radical expressions. And if you're keeping up with your notes, this is number 19. And shouldn't we end up with about 25? Somewhere around 25, maybe 26 different assignments that we've done. So if you're keeping up with your notebooks, again, we've got 2 more weeks of taking notes, and after that, we'll wrap it up and start checking notebooks after that. So, all right, so here's the big thing that we're looking at. When we're talking about radicals, we're talking about, again, just kind of keeping it as general as we can keep it here. That when we're going through these, the number that's at the top inside the corner of this radical that's here, they call that the index. And most of the time, though, we call that the root. So they kind of flip-flop back and forth from calling it the index or the root. The number on the inside, and y'all may or may not remember this from way back when you're doing division, radicand. It's kind of like when you're doing division, the radicand was on the inside. This one's pretty much the same thing, that the radicand is your inside number. And if they were describing this and talking about what this thing is, they would call this an nth root radical. All right, here's what it comes down to. And we'll do something again. The thing today is what we're going to do today should all work out to be really easy. This is more of kind of previewing where we're going tomorrow with a lot of the stuff that's here. But when we're coming to the radicals and everything we're doing, and again, we've already sort of done some of this, so this shouldn't be anything too awfully brand new when it comes off of it. Here's what you want. You want to simplify the radicand as much as possible. And then write it in factored form. And again, this is really what we're going to do today. A lot of these you're going to look at and go, "Oh, I don't have to do that because it's so easy that the problems will be okay." Again, this is kind of more building to what we're going to do tomorrow more than what we're doing today. And here's kind of what we're doing. That if this works out perfectly or in an ideal situation, you want to have the nth root of b to the n. And if this is kind of going back to when we were doing square roots way back when, how we had to have our exit buddies. We were working on numbers and breaking numbers down and doing different things with it that we had to have exit buddies. This one's kind of that same thing that we're going through. And the reason if we do that is that if the index and the power so if the index or the root, whatever they want to call it here, and the power of the radicand are the same, then they cancel each other. Okay, so the nth root and the nth power would basically cancel each other out. That's going to leave you with an answer of whatever that number is. Whatever the number be, that's whatever the answer is going to be. And that's what we're trying to do. So this is where we're trying to get the exit buddies to match up with the index that's on the outside. And again, we've already sort of kind of done this, but we're just going to kind of go through and do some things here with it. And really, it comes down that we got 2 different things we're looking at. We've got one with variables and one that's not. So we're going to do this part without all the variables that's here, and then we're going to throw in some variables, and we're going to add in like one little detail on the variable part of it. All right, and there's two different types of examples. All right, and the first type is going to say to list all roots. And when it says to list all the roots, basically here's what we're doing. It's almost, I hate to say it's like a two-part question even inside that one, but if it says list all the roots, here's what it is. If you have an even index, then in your answer, you have to use plus or minus in your answer. Okay. Now, if it's not an even index, then you don't have to worry about it. But if it's an even index problem, when you do these, you've got to use plus or minus in the answer. And when you see this one, you'll look at it and you'll go, okay, well, then we've got it here. So, for example, one, if it says to list all the roots, and they give you the square root of 25. Well, it could be that if you do 25, and here's kind of what they're thinking, is that you could do, you don't have to necessarily write this one down, but it could be that you could do 5 times 5 and get 25. You also could do -5 times -5 and get 25. So they're kind of looking at this one and saying, all right, well, this thing could be 5 squared, or this number could be -5 squared. So if they ask you to simplify this one for your answer, you're just going to put plus or minus 5 for your answer. No, because what you would be doing is that you'd be taking the square root of that. And if it's square root, then it's understood that that's a 2 that's here. So this second index would cancel that power, and that would just get you 5. Same thing for this one. If you took the square root of -5 squared, those would cancel and get you -5. So that's where they tell you just put the plus or minus on that thing. Just like if they had the square root of any number you could think of, if it's a perfect square root number. If it's square root of 100, well, that's 10 times 10. The only thing you have to do is just make sure you put a plus or minus with the 10. If they bump it up to, let's say, like fourth root of 16. All right, now, with fourth root, that's something that we don't do a lot of. There's kind of a good news, bad news on this one. Here's what they technically want you to do. That you would take 16 and start to break it down. It's 2 times 8. 8 would be 2 times 4. 4 would be 2 times 2. So 16 would be the same thing as 2 to the 4th. So your fourth root and your fourth power would basically cancel each other out. So the thing would just be 2. And because the index is 4, we're going to put a plus or minus on the 2. Because it could be that this could be -2 times -2 times -2 times -2. So again, they say, all right, well, in this case, it could be a plus or minus 2 for one like that. All right, now if you and everybody's calculator works a little bit different, but if you're using the calculators that we've got here in class, the TI-30s that we have here, it took me a while to figure this one out for the longest time. But on these, the way that you get obviously you can do square root that's here. That one, you get this one. But if it's something other than square root, if it's fourth root or something like that, what you have to do for these is you hit the number that's here. If it's fourth root, then you have to start with a 4. You hit your second, and then your rooftop button. It's right here. You hit your rooftop button, and it puts an X here. So what it does is it takes that 4 and puts it in place of the X that's up here. So then that becomes the fourth root of, and then you can put in 16, and it will tell you that the answer would then be 2. Okay, now, and again, all the other calculators, I don't know how they work. If you're working through some of these and you want me to help you with those, you can. And again, what we're doing today, everything today is going to come out to be a nice, perfect whole number answer. Tomorrow, calculators aren't going to be as helpful, because tomorrow we're going to do one where we may do one like this where we're going to be doing the fourth root of like 32, and we're going to get a decimal number, and you're not going to be able to do it on the calculator, because that one you're actually going to have to know how to do it by hand to get there. The calculator today is more of just a check for you, that if you do one of these, you want to check, make sure you got the right answer, then you can kind of check it. So, kind of getting us there. So this is, again, showing you that one to kind of help you get through today to check it, but tomorrow you're going to have to know how to do it more like this to kind of get there. All right, let me give you one more of those. All right, now, if the index happens to be odd, if it's third root, you do not have to worry about the plus or minus. Because if you do the third root of 8, again, we check it. 8 would be 2 times 4. That would be 2 times 2. Third root of 8 would be the same thing as 2 to the third. So again, your third power and your third root would cancel each other out. That one would just be a 2. All right, and you do not have to worry about the plus or minus if the index is even, because what happens if you do -2 times -2 times -2? Yeah, it's -8, right? It's not +8. So if it's an even index, there's only one answer. Or sorry, if it's an odd index here, there's only one answer. Because if you multiply, 2 times 2 times 2, that'll get you 8. But if you make that negative, then that would end up being -8. So if, the other answer, if we kind of stick with that same thing here, if that was the third root of -8, well, then we would have that answer would be -2. Okay, and more than likely in the directions, this would say just to find the root. They'd probably change the directions a little bit, but sometimes if they just do general directions, just thinking that it says if it lists all the roots, if that's what it says, then if you have an even index, you have to use the plus or minus button in your answer to kind of get there. If it's just, and again, if it's an odd index, then no, it's just one answer. It's either +2 or -2 or whatever the number may happen to be when you're working through with it. Okay, so that's one of the options that they may get to you. Here's the second type. So if this is type A, where it says list all the roots, well, here's the second type that kind of fits more in just like the whole category. The second thing they're going to ask you to do after they give you a couple of problems is they're just going to say to simplify. And if it's simplify, there's only one answer. That for this one, basically, you do not use your plus or minus. No matter what. So this one, there's only one answer that you're going to have. There is no plus or minus. There's one answer and one answer only that you're looking for. Okay, so this one's a little bit easier, that if they ask you for the square root of 25, then the answer is just 5. Okay, so that's really the only big difference that you have. If it says simplify, you just give me one answer. If it says list all the roots and we did square root of 25, you'd have to put plus or minus 5. So that's the only thing you really have to be careful of, is what they tell you. So if it says list all roots, you got to do the plus or minus if we're doing square root of 25. If it just says simplify, then you can just tell me that the answer is going to be 5. Okay. All right, and what we're going to do, we're just going to run through a bunch of different examples on this one so you can kind of see what it all looks like, just to make sure everything is good here. So for example 2, let's say you've got to do the fifth root of 0. Now, and again, technically, and you don't have to write this part of it down, but technically, they would say, all right, well, you need that to be 0 to the 5th power. So that would cancel. But again, if you're doing the fifth root of 0, hopefully, 0 times 0 times 0 times 0 times 0 is 0. So for this is one that it doesn't matter if that's the 5th root or the 15th root or the 573rd root. If you do any root of 0, it's going to equal 0. Kind of along that same line, if you were doing the, the 71st root of 1, well, 1 times 1 times 1 times 1 times 1 times 1 times 1 is all day long is 1. So it doesn't matter how many times you do a root of 1, the answer is just going to be 1. So sometimes they'll sneak in some that's just you're like, well, I don't even have to think about that one because, any root of 1 is going to be 1. Doesn't matter what you put with it there. And almost the same thing with 0 because it's always that same number times itself there. Okay. With the negatives, let's say it was the 7th root of -1. That basically, if you have an odd index here and the number is negative, the answer has to be negative something. In this case, again, if we're doing the 7th root of 1, well, 1 times 1 times 1 times 1 times 1 would be that. So this answer would just be a -1. All right, now let me give you a number that's not, that easy. Let's say we're doing the 5th root of -32. Okay, so here's technically what we've got to do. We've got to rewrite this thing so it's the 5th root of something to the 5th power. So we've got to just basically take the -32 and break it down until we can figure out what that 5th power is going to be. We would do -2 times 16. 16, you can rewrite that as -2 times 8. 8, you can write that as -2 times 4. And then 4 would be -2 times -2. So there's your 1, 2, 3, 4, 5 -2s that you have there. Okay, so 5th power, 5th root, they cancel each other out. So in that case, the answer would just be -2. Okay, and again, if you're going through these, the only difference between if it's an odd power or an odd index that's here, odd root, the only difference between -32 and +32 is this answer is going to be a negative because we started off with a negative in here. This answer basically will be the same thing, but it's just going to start and finish as a positive number. Because instead of being a -2, this would just be a +2 when we're doing the 5th root to the 5th. Okay, so odd roots are a little bit easier. If you start with a negative number, you're going to finish with a negative answer. If you start with a positive number, you're going to start with a positive answer. So anytime we're doing odd roots, it always has that same pattern, whether it's 0 or 1 or -1 or -32 or 32. It's always the same. It's easy because whatever the sign is to start with, that's what the answer is going to be. Starts off positive, the answer is positive. Starts off negative, the answer is going to be negative. All right, square roots, 4th roots, 6th roots, those are the ones you have to be just a little bit careful of. And again, a lot of these are going to be easy because a lot of this is stuff that you're going to look at and you're going to go, well, that's really not bad at all. Because you may get one where you maybe have a fraction. You've got the square root of 49 over 64. That if you broke that up into 2 pieces, we did the square root of 49 over the square root of 64. Well, that would be 7 over 8. Okay, so if they give you a fraction answer you're to start with in the question, then you're going to wind up with a fraction answer. If they give you a decimal number, and again, this one to me is just always kind of screaming as a calculator type question. But if it was square root of 9, we know it would be 3, so we've got to do something with 3. And again, you can do it a couple of different ways, but if it's square root, to me, it's really easy. That was one you just kind of punch it in the calculator. Because it'd be 0.3. Okay, so if it's 3rd root of -27, Again, we know the answer is going to be negative because we're starting with a negative number. And if that's the case, then that's one where you just kind of forget about the negative for a minute. Just take the 27 and start to break it down. So it's 3 times 9. It's 3 times 3. So that's just 3 times 3 times 3. That'd be 3 to the third. Again, the only difference is in this case when we break this thing down. So 27 would be 3 to the third. The only difference is since this is a negative 27, it's just going to be negative 3 to the third. Again, your power and your index both cancel out. So then you wind up with negative 3. Okay, now here's one you've got to be, and this is something that might sneak in on a problem here and there based on what's happening, is that you may get one of these that'll sneak up on you. What happens if we do the square root of negative 49? All right, now this is something we talked about. So there's like 2 or 3, and this is one I want y'all kind of answer for me here. If it's square root of negative 49, this will be our Starburst question of the day. What's one answer we could possibly get off of this thing? Or what could it be? 7. Close. Now think back to something that we've done in the past here. So we're going through this. If it was square root of 49, if we took the negative off, that would just be 7, right? What happens when we throw the negative inside the square root? What does that do with the answer? Which in that variable is the I variable, right? So if it's square root of negative 49, you go. Y'all remember when we're doing negatives, we had an imaginary answer, right? This wasn't a real number answer. And when we start talking about the homework on this and going through these, they're not doing everything in this part. We're not doing anything with imaginary numbers. Everything has to be real. So if this was an imaginary answer, for now they're saying, all right, imaginary is off the board. Well, if we can't use imaginary, then that was going to be no solution. And again, if you were to check that one with your calculator, that's when your calculator is going to get mad at you because it's going to go, no, you can't do that. Do square root of negative 49. We get a domain error, no solution. And there's where we're kind of throwing this thing out there. So if they happen to sneak in, now, if it's an odd power or an odd index out here, like this one was, you get a number because, again, you can do a negative times a negative times a negative, and the answer will be a negative. But if it's an even index out here and they give you a negative number, it's no solution. Because if you do negative 7 times negative 7, well, that's a positive 49. And of course, if we do 7 times 7, that's definitely a 49. So there's no number that you can do to the second power that's going to give you negative 49. Now, again, imaginary, yes, we can throw that in there, but for now, imaginary is off the board. So forget about that one because it's got to be a real number that we can throw in there. Okay, so just kind of keep that one in mind. If you happen to run across, if they happen to sneak in a second root or a fourth root or any even index that's here for the root, if it happens to be even and you've got a negative number, then that's going to be a no-go. Then you got no solution there. All right, now we're going to throw variables at you. But here's the thing. Variables, I kind of like variables. Variables, to me, are easier, especially when you start changing the powers and index because, if I ask you to the square root of 49 or square root of 64, everybody's good on square roots as long as the numbers aren't too big. Variables are kind of good because no matter what you do with variables, the simplifying part is really, really, really easy. So this, if you need a moment of the day, this is a moment of the day because if you watch this one, this is where it gets really easy. To simplify variables, you're going to do one simple little thing. You're going to divide the power of each variable in the radicand by the index or the root, whatever which they call it there. And that's it. That's all you have to do. So that, to me, that one is really easy because I just do one simple little thing and I've got the answer. All right, now here's the catch. Here's the question. Here's the one thing. This is the little thing you've got to be careful of on this one. And it's one of those things that we kind of go over it now, but then once we get past this, we don't worry about this one anymore. So this is the one little detail you've got to worry about for this section. If the index is even, and your variable answer is to an odd power, you must put absolute value brackets around the variable. All right, so we'll give you some that, again, just have to kind of look at what the options are. So we've got the third root of, let's do x to the 12th and y to the 18th. Okay, it says if the index is even, this is an odd index, so we don't have to worry about this. So if the index is odd, don't worry about it. Now we're just dividing. We're going to take 12 and divide it by 3. And for the y, we're going to take 18 and then divide it by 3. And you go, well, that's not bad. 12 divided by 3 is 4. 18 divided by 3 is 6. And there you go. And that's just all you have to do for your answers. All right, if they happen to throw a number in there, let's say if we're doing the fifth root of 32, x to the 10th and y to the 40th. You basically do it in three, you basically break it apart. We're going to do the fifth root of 32. We're going to do the fifth root of x to the 10th, and we're going to do the fifth root of y to the 40th. So you can do each one and break it apart in little pieces and do each little piece of it here. If you go back and do the fifth root of 32, that was the same thing as 2 to the 5th. So for the x, we're going to take 10 and divide it by 5. For the y, we're going to take 40 and divide it by 5. Well, fifth power, fifth root cancel each other out. That's just a 2. For the x, 10 divided by 5 is 2. And then 40 divided by 5 is 8. Okay, so as long as the index is odd, we don't have to worry about checking anything. All right, so for example 3, we're going to give you one where it's even. We're going to make it really easy for this thing. We're just going to do the square root of x to the 6th. Okay. All right, again, here's our detail. If the index is even, we've got to put absolute value brackets around the answer if it's an odd power. So first thing is, again, it's the second root, because if there would not have anything there, it's understood that would be a 2. So it's x to the 6th divided by 2. So that's x to the 3rd. Okay, so the index is even, so we got to be on details. And the answer has a variable to an odd power, which we've got here. You've got to go back and put absolute value brackets around this thing. Okay. And again, after the section, after we get through today, we don't have to worry about this one. This is just a one-day thing. It's a minor little detail that we can get through, and I'll explain it in a little bit of why this is, why you have to do that. But the main thing is just realize that this is the one little thing that you got to check that we're going through this one. All right, let's give you maybe a couple more of those, and we'll wrap this thing up here. All right, so let's do the square root of 81 x to the fourth. All right, so what we're going to do is we're going to break it up, think about it as just the square root of 81, and then it's the square root of x to the fourth. And again, without an index there that's understood to be 2, square root of 81 is 9. If we do the x to the fourth divided by 2, that's going to make it x squared. Okay, and we said that the answer has an odd power. In this case, it's an even power. So if it's an even power in the answer, we don't have to put the absolute value. We can leave it just like it is. All right, now here's the big reason that they're doing that one is that in this case, they're assuming that if the number that we've got here is going to be positive, if you do x to the sixth, if that number happened to be a negative, let's say we were doing like this was like -2 or something like that. Well, if you do -2 to the sixth power, eventually that's going to make that a positive number. And so if this answer came out to be this one and x was -2, we've got to do the absolute value of -2 so that basically the answer stays positive. All right. And for this one, the reason you don't have to do anything with this one is that if this was a negative number, when you square a negative number, it's going to make it positive. So that's why you have to kind of do it. So again, it's not a big detail. It's not a huge detail. It's just one of those little details they're going to throw at you here in the first section that you've got to kind of worry about. So, all right, let me show you one more problem, and then we'll wrap this thing up for the day. All right, so let's do the fourth root of x to the 12th and y to the 16th. Okay, and again, all we're going to do is take each of the variables we've got here and divide them both by 4. X to the third and y to the fourth. Okay, and then some people go, well, what do we do on this one? Because that one's odd and that one's even. If whichever one it happens to be, if it's odd, in this case for the x, you would put an absolute value around that one. But since y to the fourth is even, you don't have to do that one. So then that would be your final answer.